Next point is increasing function and decreasing function. So the function is called increasing function if x1 is less than x2 implies f of x1 is less than or equal to f of x2. That is the sign less than continue, then we say the function is increasing. If there is less than, then if it is continue to that less than, then we say the function is increasing function. And the function is called decreasing function if x1 is less than x2 implies f of x1 is greater than f of x2. That is the sign reverse, that less than becomes greater than. So these are the definition of increasing function and decreasing function. So some example of increasing function and decreasing function. Fx is equal to x square plus 2 is increasing function. Why is increasing function? Because if you observe 1 is less than 2, then what is f of 1? F of 1 is 1 square plus 2, that is 3. And f of 2 is what? 2 square, that is 4 plus 2, that is 6. So we have this f of 1 is strictly less than f of x2. And so this is the strictly increasing function actually. That is, if x1 is less than x2 implies f of x1 is strictly less than f of x2, then we say the function is strictly increasing. Okay. And if x1 is less than x2 implies f of x1 is less than or equal to f of x2, then we say the function is increasing. Similar definition for strictly decreasing function. That is, if x1 is less than x2 implies f of x1 is strictly greater than f of x2, then we say the function is strictly decreasing. So this x square plus 2 is strictly increasing function or increasing function. If we observe f of x is equal to minus x, then this function is decreasing function. Why? Because if 1 is strictly, we know that 1 is strictly less than 2. Then what is f of 1? F of 1 is minus 1. F of 1 is. And f of 2 is minus 2. And we know that minus 1 is strictly greater than minus 2. That is f of 1 is greater than f of 2. That is 1 is less than 2, but f of 1 is greater than f of 2. And therefore this minus x is the decreasing function. So there are theorems on this increasing function and decreasing function are called characterization theorem. That if the fx is be the function continuous and differentiable on open interval AB, and if f dash x is greater than 0 for all x belongs to open interval AB, then fx is said to be strictly increasing in the interval, closed interval AB. Okay, that is the derivative f dash x is greater than, strictly greater than 0, then we say the function is increasing function in that interval. And the function fx is said to be, suppose this function fx is continuous and differentiable on open interval AB, and f dash x is less than 0 for all x belongs to open interval AB, then fx is strictly decreasing, or say, just say decreasing function on the interval, closed interval AB. That is the derivative of the function is less than 0, then we say the function is decreasing. And if the derivative f dash x is greater than 0, then we say the function is increasing. So, and if the f dash x is 0, exactly 0, then such a point are called stationary points or critical points or points of relative extrema. So the example, find the points of relative extrema and separate the intervals in which the polynomial fx is equal to x cube plus 8x square plus 5x minus 2 increasing or decreasing. So we have to find first the point of relative extrema or the critical points. So we have to find the critical points or stationary points. So how we can find the critical points or stationary points? Just solve this equation f dash x is equal to 0, and the roots of this equation f dash is equal to 0 are the stationary points or critical points or points of relative extrema. That the function is maximum or minimum at that point. Maximum or minimum at that point. So fx is x cube plus 8x square plus 5x minus 5. So its derivative f dash x is what? 3x square plus 16x plus 5. Then consider equation f dash x is equal to 0 in order to find critical points or stationary points or points of relative extrema. Consider equation f dash x is equal to 0. Then that is 3x square plus 16x plus 5 is equal to 0. Then we have to find the roots of this equation. So the factorization of this 16x is 15x plus x, because this 3 into 5 is 50. So, and 15 and 1 addition is 16. Then take 3x as common. So we have x plus 5 in bracket. Take 1 as common, x plus 5. Then take x plus 5 as common. We have 3x plus 1 in another bracket. So x plus 5 is 0 or 3x plus 1 is 0. So x is minus 5 or 3x or x is minus 1 by 3. So these minus 5 and 1 by 3 are what? Are points of relative extrema. Right here the sentence that minus 5 and minus 1 by 3 are points of relative extrema, or are the points, stationary points, or are the critical points. Right here sentence that minus 5 and minus 1 by 3 are points of relative extrema. Then we have to find the we have to divide this interval. Next question is what? Separate the interval in which the points in which the polynomial is increasing or decreasing. So we divide this interval minus infinity to infinity, that is the real line, in this fashion, that is minus infinity to minus 5. Show this minus 5 and minus 1 by 3. Here is minus 1 by 3. Then we have minus 1 by minus 5 at this place, minus 1 by 3. So we have take the intervals minus infinity to minus 5 as the open interval, then minus 5 to minus 1 by 3, and minus 1 by 3 to infinity. So we have the two critical points. That's why this real line divided in three parts, three sub intervals. Now we have to find the function is either maximum, the function is decreasing or increasing in these three intervals. So now consider the first interval, minus 5, minus infinity to minus 5. And in this interval, we'll find the value, the sign of f dash x. So f dash x is what? F dash x is, now f dash x is x plus 5, x plus 5 into 3x plus 1. It's simplification. F dash x is x plus 5, 3x plus 1. So in the interval minus infinity to minus 5, x plus 5 is less than 0. We take any point between minus infinity to minus 5. So in between minus infinity and minus 5, there is minus 6, minus 7, minus 8. These are the point between minus 5, minus infinity and minus 5. So if you substitute minus 6 here, a value of x as minus 6. So minus 6 plus 1 plus 5 is minus 1, less than 0. If you take minus 8, the point between minus 8, minus infinity to minus 5. Minus 8 plus 5 is minus 3, is less than 0. So for the values of x between these two, these interval minus infinity to minus 5, this x plus 5 is less than 0. And 3x plus 1 is also less than 0. Because if you substitute x as, suppose x as minus 6. So x as minus 6. So minus 6 into 3, minus 18 plus 1 becomes minus 15. And this is less than 0. So both the quantities are less than 0, and therefore their multiplication is greater than 0. Because multiplication of negative and negative is positive, greater than 0. And therefore f dash x, it is x plus 5 into 3x plus 1. Here is the simplification of f dash x is greater than 0, because x plus 5 is less than 0, 3x plus 1 is less than 0, and therefore their multiplication is greater than 0. And therefore the function fx is increasing in this interval minus infinity to minus 5 because of this theorem. The derivative of the function is greater than 0, and therefore the function is increasing in that interval minus infinity to minus 5. Then consider the next interval, minus 5 to minus 1 by 3. So in this interval, what do we have? X plus 5, value of x plus 5. So between minus 5 and minus 1 by 3, the point are what? Minus 4 is the point between these two. Minus 3, minus 2, minus 1. These are the point between this minus 5 to minus 1 by 3. Minus 5, then minus 4, then minus 3. So substitute, suppose x as minus 4. So minus 4 plus 5 become 1, and it is greater than 0. If you substitute minus 2 as a value of x, then it is minus 2 plus 5 is 3, and it is greater than 0. So between these two, between this interval, if you substitute x any value, then x plus 5 is greater than 0. And in this interval, 3x plus 1. So substitute x as, suppose, minus 4. So minus 4 plus into 3 becomes minus 12 plus 1 becomes minus 11. That is less than 0. So in this interval, the 3x plus 1, value of 3x plus 1 is also less than 0. This is greater than 0. and this is less than 0. X plus 5 is greater than 0, and 3x plus 1 is less than 0, and therefore x plus 5 into 3x plus 1 is less than 0, because the multiplication of one positive quantity and one negative quantity is negative. This x plus 5 is positive, 3x plus 1 is negative, and therefore their multiplication is less than 0. That is, f dash x is strictly less than 0, and therefore fx is decreasing in this interval, minus 5 to minus 1 by 3. The function is decreasing because in this interval f dash x is less than 0. And the second theorem is what? That if f dash x is less than 0, then the function is decreasing in that interval. So the function is decreasing in this interval. Then last interval is minus 1 by 3 to infinity. Now in interval minus infinity to minus 1 by 3 to infinity, x plus 5. So between this minus 1 by 3 and infinity, the point 0 lies between these two. Point 1, point 2, point 3 lies between this. So if we substitute x as 3, which the point between these two, point of this interval, suppose x is 3. So 3 plus 5 is 8, and 8 is greater than 0. So x plus 5 is greater than 0. And if we substitute x as 3, 3 into 3, 9 plus 1, 10 is also greater than 0. So in this interval, minus 1 by 3 to infinity, x plus 5 is greater than 0, and 3x plus 1 is also greater than 0. And therefore, f dash x is equal to, and so f dash x is equal to x plus 5 into 3x plus 1. That is the multiplication of these two positive quantity is greater than 0. Multiplication of two positive quantity is positive, greater than 0. And therefore, fx is increasing in this interval. So these minus 5 and minus 1 by 3 are points of relative extrema. And the answer of the question is that separate the intervals. So these are the intervals. So in this interval, in the first interval, the function is increasing. In the second interval, the function is decreasing, and in the third interval, the function is increasing. Okay. Now, the same question for homework assignment, that fx is equal to x square minus 3x plus 5, and this fx is 2x cube minus 9x square minus 24x plus 16. So question is what? Find the points of relative extrema and separate the intervals in which these functions are increasing or decreasing. Okay. So next type of the question is show that this inequality. So the first is what? X minus x square by 2 is strictly less than log 1 plus x is strictly less than x minus x square divided by 2 in bracket 1 plus x for all x greater than 0. Similarly, the second one, similarly the third one. Okay, and similarly the fourth one. So the proof of the fourth, third one, second one, first one. Okay, so we have to prove this. X minus x square by 2 is strictly less than log 1 plus x is strictly less than x minus x square by 2 in bracket 1 plus x. Now consider the function fx as log 1 plus x minus in bracket x minus x square by 2, and show this function is increasing function. So what we have, log 1 plus x minus the simplification minus x plus minus 1 has become plus x square by 2, and then f dash x, its derivative is 1 by 1 plus x, derivative of log 1 plus x minus derivative of x is 1, and derivative of x square is 2x divided by 2 means x. Take a 1 plus x as LCM. So 1 minus 1 plus x in bracket plus x into 1 plus x in bracket. So 1 minus x plus x square becomes x square by 1 plus x. And this quantity is greater than 0 for all x greater than 0. We are given that x is greater than 0. X is already positive. So 1 plus x is now positive. And x square is always positive quantity for all x. So positive divided by positive is positive. So x square divided by 1 plus x is greater than 0 for all x greater than 0. And therefore, the function fx is increasing in the interval 0 to infinity. The interval 0 to infinity. So that is for all x greater than 0 means from the 0 to infinity, the function is increasing. And as 0 is strictly less than x, this 0 is less than x, therefore f of 0 is strictly less than f of x, because fx is increasing function. As the function is increasing, So sign less than continued as less than. Okay, by using the definition of the increasing function. What is the definition of increasing function? The function is increasing, then what happen? If x1 is less than x2 implies f of x1 is also less than f of x2. So 0 is less than x, and therefore f of 0 is strictly less than f of x. And what is f of 0? So if you substitute x as 0 in this example, so log 1 plus 0 means log 1 is 0, and this quantity is 0. So f of 0 is 0. F of 0 is 0. And fx is what? Log 1 plus x minus x square by 2. This is fx. Log 1 plus x minus in bracket x minus x square by 2. So we have 0. F of 0 means 0 is strictly less than f of x means this log 1 plus x minus x square by 2. Shift this, add x, this quantity in both sides. So what we have? That is, shift this negative quantity to LHS. X minus x square by 2 is less than, strictly less than log 1 plus x. Okay, and this is the half part of the example, that x minus x square by 2 is strictly less than log 1 plus x. Similarly, we have to show this now. Log 1 plus x is strictly less than x minus x square divided by 2 in bracket 1 plus x. That is why to show this part. Okay, and so for this part, again the same procedure. Consider the function gx as x minus x square by 2 in bracket 1 plus x minus log 1 plus x as a gx, x minus x square by 2 in bracket 1 plus x minus log 1 plus x, and show this function is again increasing. And how we can show this function is increasing? Find its derivative first and show its derivative is greater than 0. So g dash x, right here, g dash x right here, g dash x is equal to derivative of x is 1, and then 1/2 is constant, and x square divided by 1 plus x, this is the derivative by using the rule u by v rule. So 1 plus x square, derivative of x square is 2x, minus x square, derivative of 1 plus x is 1, divided by 1 plus x bracket square v, derivative of u minus u, derivative of v divided by v square, minus log 1 plus x, derivative 1 by 1 plus x, then 1 minus 1/2. This simplification is 2x plus x square. 2x plus x square. The simplification, because we have 2x plus 2x square minus x square become plus x square. And then take 1 plus x square as LCM. So 1 into 1 plus x square is 1 plus x square, the x bracket square, minus 1/2, this 1/2. Then 2 in bracket 2x plus x square, minus 1 by 1 plus x. So out of 1 plus x square, 1 plus x square is there. So multiply 1 by 1 plus x. So minus in bracket 1 plus x in bracket. Then the simplification of this is this square. Then simplification is this minus 1 minus x. And then simplification is 1/2 x square. We have 1/2 x square. Remaining quantities get cancelled. So 1/2 x square divided by 1 plus x square bracket square. And this quantity is greater than 0 for all x greater than equal to 0. Because 1 plus 1/2 x square is always greater than 0. And this quantity is always greater than 0. Actually, it is greater than 0 for all x. But here we are given x is greater than 0. So this quantity is greater than 0 for all x square, for all x greater than 0. And therefore, this function gx is the increasing function in the interval 0 to infinity. As 0 is less than x, g0 is less than gx as the property of increasing function. So as 0 is less than x, so g0 is less than gx. What is g0? g0 is 0. If we substitute g, this is gx, that x minus x square by 2, 1 plus x minus log x. What is g0? So let's substitute x as 0. So we have 0 at this place, we have 0. At log 1 plus 0 means log 1 is 0. So g0 is 0 and gx is this. So substitute g0 as 0, gx as this quantity we have, and then shift this log minus log 1 plus x to LHS. So log 1 plus x is strictly less than x minus x square by 2 into 1 plus x. And this is equation second. So from 1 and 2, we have this equation. Combine the equation 1 and 2. From 1 and 2, we have this, that x minus x square by 2 is strictly less than log 1 plus x. X is strictly less than x minus x square by 2 in bracket 1 plus x. So similar, give the proof of second, third, and fourth that show this. In order to show second, first consider fx as tan inverse x minus x by 1 plus x square, like this. And then find f dash x and show f dash x is greater than 0. F dash x is greater than 0 for all x greater than 0. Then function is increasing. And then consider as 0 is less than x, therefore f of 0 is less than f of x. We have this part that x by 1 plus x square is less than, strictly less than tan inverse x. This is the part first. And in the part second, let gx, define gx as x minus tan inverse x. And then find g dash x and denote that g dash x is greater than 0 for all x greater than 0, and therefore the function gx is increasing as 0 is less than x, g0 is less than gx, and then we have this similar proof for this third example, that is show, find first, define log fx as log 1 plus x minus x by 1 plus x, and in the second part define gx as x minus log 1 plus x. Similar, this is the last fourth one. In first part, define fx as log 1 plus x minus in bracket this, okay, and show this fx is f dash x is greater than 0, that is the function is increasing, and then we have the first part. And in the second part, assume that gx as x minus x square by 2 plus x cube by 3 minus log 1 plus x, and then find its derivative, that is g dash x, and show that g dash x is greater than 0, that is the function gx is increasing, and then 0 is less than x, g0 is less than gx, and give the proof. Okay, so these are three example, number 2, 3, 4 are for assignment. So solve all these examples in your assignment notebook. So this is the first chapter, that differentiation. So in the second chapter, we will see the L'Hospital rule and successive differentiation. So we'll see this chapter in the next lecture.